Hey everybody, this is Larry. This is me going Q4 of the weekly contest for 36. Maximize the minimum game score. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one, it's a little bit tricky for me to kind of analyze. It took me about an hour to do this problem, but honestly, I kind of had about 90% of the code, like about 5 or 10 minutes in. Yeah. I mean, this one also, it's a little bit hard to read, of course, so you have to read it correctly. But basically, the idea is that you start an index, you can go left and right, and then add score along the way. There is, for me anyway, a very intuitive binary search in that, okay, let's say the minimum score is this, then what does that mean? Well, if the minimum score is a certain target, well, I just call T for target, then that means that you have to visit index 0 p sub I over target, or the other way around, T target over number of points times, right? Let me draw it out actually. Hang on. Right, and what I mean by that is that, okay, so for example, actually let's use one of the examples, right? Those are actually crappy examples, but yeah, let's say you have, I don't know, 6, 13, 19, 13, 12 or something, right? So then now, well, what do you want to do? Well, if we want to get the minimum score to be, I don't know, 20, right? What does that mean? That means that we have to do this. We have to be here at least 4 times, right? Because we have to hit 6 3 times to get 18, and to hit 20, you hit it 4 times. Here, you have to hit it twice. Here, you have to hit it twice. Here, twice, and 4, right? So that's basically what I call the requirement for 20, right? And what that means is that, okay, then now it reduces to be a problem to, can we, we start at -1, right? Can we go to, can we draw a path such that we visit it in the minimum number of times? And yeah, I just want to kind of step back a second and say that I know that I kind of jumped really ahead with the binary search. This is a very hard problem. Only 150 people solved it live. So I'm going to say that if you're not strong at binary search, you should, I mean, it took me an hour, right? Whether I have silly mistakes or not, it took me an hour. So you need to be good enough at binary search for some definition. So I'm not going to go over that for this problem or this video. Hopefully that's understandable. I think the cocoa having bananas or something problem is a problem that I would play around with. If you get that one, then you can come back, because I think that one is and similar problems to that one, and there are many problems, will allow you to kind of get an idea of what this problem is like. But yeah, the funny thing is that it turns out that everything is forced. I actually, during the contest, and you know, in my videos, I like to go over what I've done wrong as well, hopefully as a teaching lesson both for you at home and for me in the future. And the reason why I do that is just because, well, I don't know, I think it's unique and different, right? Versus, you know, mistakes that, you know, a good quote unquote engineer makes, right? But also that, you know, just kind of like, I think the thing that I learned not necessarily is like how I got it wrong, but just to kind of be able to reset, refresh, and challenge your beliefs on a problem. I think that's the key takeaway that I would take for this problem. As you know, I did this in an hour, and if you look at the, I guess I'll show you the leaderboard in a little bit. I guess now, right? Why not? Right? If you see here, I solved it with a minute to go in this problem. So there are 2 things. One is don't give up. Keep going all the way to the end. I mean, it doesn't have to be Q4, it could be Q3, whatever your challenge is, go all the way to the end. Run through the tape, right? As they say in running. And yeah. But also like being this ability of like re-examine myself. And the reason why I was wrong on the first time, and I'm not going to go over this part too deeply because I don't even know how to explain it. I think there is a right solution to it, but I just couldn't figure it out, right? And what I mean by that is that, so we know that we have to scan from left to right, and we know that we don't do it in either linear time or n log n time at worst, because otherwise it's just too slow, right? We already binary searching the 20, so that's already going to be a log m factor for some log m, so we know that we have to do this in O of n time-ish in order to be competitive. So as a result, we have to figure out how to do it, right? And the way that I did it is for each number, I just look at the previous number. And it turns out this is really, really hard to do. Why? Why is it really hard to do? And why? And I couldn't get it, frankly. Why is it hard to do? Because for each cell, we look at the previous one, right? And the problem that I was dealing with is that, okay, so let's say you have 4 and the 2, then now, should this be, for this cell, if we're looking backwards and only modifying this cell, then, yeah, I think that's the tricky part, is that I'm only modifying this cell, and so, I have to take account of both the past and maybe the future. And what do I mean by that? There's a 4 here. It could be 4, 3. If the left, if the right can do it in a way such that it comes back and it goes 3 and then 4, then that is a right answer. But another possible idea is that it goes to 4, 4 because it has to go end there. And because if it ends there, then it cannot go back to the left without, you know, passing this again, and then it goes 5, 5, and so forth, right? Or 4, 4, and then it goes 4, 5, right? It'll be the next one or whatever. So that's why I struggle in hours. That I was looking at this thing, and with a lot of practice, you tend to take shortcuts a little bit with your gut. And for me, for this one, I just thought it's symmetric, or maybe not necessarily explicitly. Maybe I didn't even think that, honestly. I just think it didn't matter. I didn't think to think, honestly. And what do I mean by that? It turns out that, because and if you watch the live portion, I struggle for like an hour with like the parity of like, okay, do I get the previous? Like, how do I handle it with if statements of the previous and also the future, like of saving, like, okay, maybe in the future, if I do need some numbers in the back, then I take it of this one. I don't know. Maybe there's a way to do it, and if you are able to do it this way, let me know in the comments or come to Discord, let me know. I'll be really happy to see it. Excuse me. It turns out the easier way to think about it, though, which I did not do, well, I did. Like, I don't know the exact timing, you could watch the live portion, but with about 10 minutes to go in the contest, I go, what if I just do the loop a little bit differently? Like, I was thinking, like, okay, what if I look forward? And I don't know why it took me so long to figure that out, but it's just what it is. And what happens is that, well, it turns out if you do this, then everything of the parody and worrying about is truly where you only look about the future, right? And what I mean by that is that, okay, so the idea here is that, okay, this is actually, I don't like these numbers, they're not as interesting. So let's say we have 6, let's just construct new ones, right? Let me use the color black again. So 6, 3, 5, 4, 2, 5, 4, I don't know, whatever, something like randomish, but goes up and down, right? So then now, if we start at 6, well, we know that we have to do this 6 times, and we also know that as a result, then now we truly don't have to worry about the left, because even though you can go back to the left, of course, but going to the right will always be more optimal, just because it gets rid of the requirement as well, right? Because everything to the left, every requirement is met. So that's the difference. It's a very subtle difference, isn't it, right? Like looking one step forward, or skipping one and looking one step backwards. Because here, then now we go 6 and 3. This 6, we need to accomplish the 6, we need to go back and forth, so that, you know, we 6, right? And the key thing here is that technically, and the other invariant, which I didn't talk about for the looking back example, the what I call the I-1 case, is that it assumes that we are here, but also that the current cursor is the I-1. I think that's the key part, is that the cursor is at I-1, so then we move this cursor here, so then we already move one move, right? And then now we are here, we need 6, so then now to go back and forth to accomplish the 6, we need to go to the right 5 times, and then we end at 6, right? So that's basically the idea. And because this is 5, we kind of change this to 5 just so that we have future prosperity, maybe. Actually, I think I just convert this to 0 for we don't need anything anymore. But yeah, so then now when we move from left to right, when we move to here, move to this cursor to here, then we now processing this node, the cursor is actually here, moving it to here costs 1 move. This is a 0, so we don't even have to care about it because there's no requirement. We don't have to come back to it. So then now we move this cursor to the right. Again, now we look at here, but now this is a 5. 5, then that means that we have to go. And again, technically speaking, you can go backwards as well, right? And then go back and forth. But the thing is that if you know that everything to the left, all the requirements are met. So as a result, it doesn't, in a greedy way, it doesn't make sense to go left again. So then now you can go left and right. This is also the difference between this case of going backwards, right? When we go backwards, well, we don't, or when we go forward, we don't, this requirement is still up in the air. And what I mean by that is that this is a 2 and a 3, or like this is a 2, we made it into a 3 to satisfy the 4, but then we maybe want to make it a 4 in the future. And that is a hard statement to make, right? To go back. And I'm not saying it's impossible. Maybe we can implement some sort of stack or something like that. I don't know. But it's just that you have to do it. And I couldn't figure it out, honestly. If you can, like I said, please let me know. But here at 5, because everything to the left of it, we don't have to care about anymore. So we go back and forth to the right. And since this is a 5, we go to the right side 4 times. So that means that this is actually, this is not intentional though. But this is 0 again. But let's just say, let's quickly change this just so that I have it. Let's say it's 14, right? Then now we're back and forth 4 times. So then now we can convert this to 10 because 4 of the times here. So then now, again, we make 1 move to shift to here, and then this is 10, right? Yeah, and then we just basically do the same thing over and over again. And as you can see, the invariants are the same, right? Is that it started at the previous, you have to make 1 move. So technically you could say this is a 9, but whatever. And then all you do is go left and right in your changing assumption. And I think this, and as soon as I did that, I was able to get in a couple of minutes. I did have an if statement, I did have a thing where I was returning a negative thing, and as a result I have to fix it. And also Python gave me another time limit exceeded, but otherwise this is good. So this also honestly does not pass the time in Leetcode, but if you convert it to Java it does. So I'm just going to go over this one. Again, you can also probably write this a little bit cleaner. But this is the way I do it. Okay, so first of all, the upper bound. The upper bound was the upper bound. Well, it's I guess this could be tighter. I just took the highest m times the number of points because the idea here is that if you are in one cell 10 to the 9 times, well, you need 2 cells. But if you get 10 to the 9 moves and each cell 10 to the 6, then you go back and forth. In theory, it's like 10 to the 9 times 10 to the 6. So that's why this is my upper bound. But as a result, you can maybe do a little bit better with like, what is this? M times max points. Technically, it's the same thing, but maybe slightly better. Let me actually run it real quick. Would that be fast enough? I don't know. But while we wait, then we talk. But yeah, but that's not the important part anyway. Again, this is binary search. I'm not going to go that deeply about it. This is a very straightforward binary search. If we have the bounds, we look at the middle. So this is still time limits, unfortunately. So that didn't matter. But yeah, so if you look at the middle, if the middle is good, that means that you want to try a bigger number and also the mid is satisfied, so you do this. Otherwise, you want to constrict and try for a smaller number, so you constrict on the right side, right? So okay, so then now you have target, right? And this is, like I said, the hard part. Here, first I create the requirement array, the requirement array, right? And this is basically how many moves that we need to be here. And of course, if we need more than m, then we just return 4. So it makes it a little bit faster. And maybe I didn't need to, I don't know. I don't know how, because it is not fast enough, which is kind of sad. Because when you convert to Java, it's fast enough. But anyway, yeah, we'll just go with the logic. Maybe you can win this a little bit better, but I don't know. Anyway, so yeah, so turns is equal to 0, right? And then now again we go from given I, we look at I and I plus 1. So if we don't need any more, then we just go 1 turn because you still have to visit here. The idea here is that you also need 1 turn is because to the right, everything, if you have a number, the number is always at least 1. So you always need to go to the right, to the last number. The last number is always going to be need of I is always going to be at least 1 because we round up here, so that's just always going to be the case, right? And even this, as long as target is greater than 1, or is at least 1, not greater than 1, it's at least 1, then this is 1, and target will be always be 1 or more. So yeah. Anyway, though, if this is 0, that means that there's numbers in the future. You just add 1 turn because, well, you still have to go here. Otherwise, then now it's equal to needs times 2 minus 1. Of course, you can think this is basically just thinking back and forth in the next cell, right? And you can think of this as plus need of I minus 1. I guess it's just natural for me to write it the other way. I didn't even actually think about it. And then delta is basically saying, okay, well, we need to get to we need to get to this number. This is the previous number. Delta is the gap that we need. So then, and this is basically just calculating how, okay, so we took this amount of turns. This is another way of saying it. We took this amount of turns. So delta is the number that we want to add to the next cell. Yeah, because we need that to be that number. This is actually a little bit confusing. But yeah. Well, because we get it to that number. And then once we get to that number, we subtract it by... Yeah, maybe this part is a little bit convoluted. But in any case, the next cell, right, we just... Because, for example, if it's 6, if this current cell is 6, then the next cell we visit it 5 times because we go back and forth 5 times and ending in this cell, which is why it's 6, right? To keep the invariant. So you only need the next cell to be x minus 1. So you subtract it. Yeah. And if it's 0, we just set it to 0 for, so that we don't have to handle negatives. That's basically it. Yeah. And then at the last cell, if we still have numbers left over, then we just do this thing again where you go back and forth. And this time you do go to the left because you can't go out of bounds, so you can't go to the right. But it doesn't matter because to the left the requirements are already met, but we're just going to it to run up the number for this number, and that's it. As you can see, this is O of n. I guess the constant's a little high, maybe, so maybe that's why. I don't know. I'm actually surprised that this is too slow, but like I said, maybe it's just Leetcode things. I mean, I could make this a little bit tighter for sure, but I don't know. It feels a little silly, honestly. But yeah. So yeah, this is going to be O of log m, where m is the number of the maximum number, or the number of bits in number, if you want to call it that way. But then I guess that's m, which is binary search. Otherwise, yeah, this is this is O of n, right? I mean, we just loop, and yeah, and that's it. I mean, you can maybe do some math so that you don't need to allocate the array. Maybe that adds up. I don't know, but yeah, that is all I have for this one. Let me know what you think. Thanks for watching, And yeah, let me make this slightly smaller so you could see the entire code. And that's it. Thanks for watching. Yeah, and you could watch me solve it live next. Remember, you could watch it and fast forward and skip near the end, maybe with the last like 10 minutes, and you'll see me going, oh, I can just look to the next cell, and that made it so much more different. And I didn't realize that I could do it that way or think about that way, which like I didn't think about it. So, and once I did, it was obvious. But sometimes that is life, and also you got to grind it all the way out because I still solved it at the end. But yeah, thanks for watching, and yeah, you can watch me solve it live during the contest next. Okay, so I don't know. So really not confident. It's not worth the gamble, I think. Anyway, okay, so we have an hour and 4 minutes left. Okay, game score of length n. There's another. What does this mean? Oh, the game score changes, so we have 2 games. Okay, I'm still not. I don't even know what this is saying, but okay. Start index -1, which also m moves. At each move, you can add 1, increase it by 1, and add points up to the game score. Decrease the index by -1. So you always have to start at the first move. That's a really awkward way of phrasing it, but after most m moves. Okay, so here we go to the 2, and then we go to the 4, and then 1 more move, we go to the 4, we increase, and then we're done. Okay, fine. 1, 2, 5, we go 1. Okay, I mean, this is actually a good example. Thanks, Leetcode, for actually putting in some effort here. The score is 2, okay. Okay, I mean, I think I understand it, but how do I do it? I don't know. And m is 10 to the 9, so you have to be a little bit smarter than that. I mean, yeah, I'm a little bit smarter than something. Okay, so what does having m mean? You don't have to go anywhere, right? So, but you have to get the, you have to maximize the minimum. So then the question is, okay, let's say we have a binary search. What would that look like in terms of moves? That means that, okay, so let's say minimum moves, then we want to do 2. But how do you do the check? The check should be simple, maybe. It just, okay, so let's say do, right? So then we just go if it's possible. This is 7 point. Is it true? Some stuff. One, right? 3, 2. One, 2, 1. So okay, let's just write it out real quick. 1, 1, and 2, 1. Okay. 2, 2, 3, 2. Okay, 3, 2, and then otherwise it's 3, 3. So okay, fine, right? Then it could go 3, 3, 1, 341, 342, right? 343, 353. I mean, that's it. I think. I mean, it's gonna be binary search, but how do you do the satisfactory? How do you check whether a thing is possible? Okay, 353, 354. Okay, so that's possible. And then 3541, 35411, 541 or 21. 35521 is possible. Don't in that way you would go 33. So then 2. Okay, what does 33 mean? Okay, 1 1 1 1 1 1 1 1 1, right? So then you have 2 4 2 1, yeah, 2 2 1 1, which is possible, I suppose. What if you have 5? Is 5 3 1 possible? No. 5 4 1 possible? So we have a number that is bigger than the next number, then it has to come back, right? What's it equals to do? Yeah, so then it has to come back. Okay, then it has to come back. Right? This was so good. I don't. Then it would have to come back, right? Because basically we have 631 as a requirement. Well, you can always just put extra values. Six 5 1 possible. 1 1 2 2 3 3 4 5 5. And then 1. So no, 6 5 1 is not possible. But 6 5 is possible. Because then you only have one case where this is true, I suppose. And only by one. I think, I don't know if I could prove that though, honestly. So, okay. Was it 10 to the 9? What is M? M is 10 to 9 moves. So 10 to the 15 is fine, right? 16. Okay, so this is possible, then we want to try a bigger number, right? Okay. Yeah, still very fuzzy to me, honestly. I think the idea is roughly right, but I don't know that I'm very precise. I probably don't need this, but I think it's easier for me this way, but I guess I could just do this. I think actually this is slightly faster, and I think I need the speed actually. Otherwise, okay, so if need of I is, this is normal, right? Okay. Fine. Otherwise, what happens if it's? I think even if it's Leetcode 2 is fine. It's only when it's not that's the tricky part, right? Remember, you can always go over. So okay, so if this is not, then there are only two possibilities. That's an annoying thing. If the previous number is bigger. Then we want to set add is equal to n minus 1 minus 1 we can do 6 5 5 5 right? 5 5 1 is not fine, but then what? 6 6 1 is fine. 6 5. But 6 5 3 is still not fine. Really? But that means that you have to add it to it. I don't know how to do this part. Huh. The idea I think is roughly right, but I don't know how to check this. Do I need to do DP maybe? Or add it and not add it? Maybe this part has a linear DP. What is it? We have 6 3 1, then this has to be at least a 5, right? So okay. So add right? Add turns we add. Okay. Just so that we have enough turnaround. Right? If last extra is not none, then we need to add one more to that one so that you go flip it forward. Right? Okay. So then if last extra is equal to I, it doesn't really actually matter. But then that just means that turns add 1. Right? And then now also technically and needs of I is equal to 0. Because this does not satisfied anymore. Yeah, whatever. And then the last one, we want to add it again because anything we have left over, we need to do it, right? Something like this, though, I don't know. This feels a little bit wonky for sure. And it's not going to be even a good answer for this one, but that's okay. It's just returning good for everything. I don't know. Turns is 2. Why? Did I do it backwards? Target. Is it over target? No, it's the other way around. You dumbo. Yeah, though actually surprisingly that part is right. Okay, 2 1. Not right, but that's okay. And it's slightly more right than the previous one. Okay, so you have 2. This feels wrong. Oh no, because it's not the beginning. Okay. Okay, so you need this feels weird though. 2. Okay, so first it tries to see if we can get the score to 4. Oh, the answer should be 4-2. I'm doing 2-1. Okay, so the 4. Okay. target turns is 4. Why does it take 4? Because it's 2, 1. It thinks it's 2, 1. And then 2, 1 is this part, and then it tries to get to 1. Turns is equal. Oh no, this is add minus need sub I. Could also be. It should not be. By definition, this should be at most 0, but we'll see. 4, 2, okay. I don't think this is right, honestly, but it is right enough for the inputs, which it's good enough for me to YOLO. To get a wrong answer so I could kind of see how to fix it. Actually, one's longer than expected, but it's just probably a long time to get a wrong answer because it does like some silly checks or something. But like I didn't expect this to be right, frankly, but I don't think I have any other ideas, so I did want to see it. But okay, so this is kind of good in that maybe there's a refinement thing, but oh, is it a binary searchable then in this case? No, it should be because it does not. Yeah, no, it should be a monotonically increasing function. Okay, fine. Okay, so 71 takes 30 turns, maybe. I don't know if that's true. But 66 takes 26 turns. That's is maybe wrong, because the matrix is 3, 7, 10. So then now 3 turns, so then it's 0, 4, 10. Okay, and then now for 0, 6. So that means that it does that's 14 moves plus 12, show me 26. And also just for reference, that's the right answer. It's not me just putting in random 69 for a random reason. 69 is also 26 by my calculations. Same as 66 actually, but oh, wait, is that true? Is this -1 because you can't wait? Okay, so there's some parity thing here maybe. Okay, so 4. Wait, we're at 3, 3. So we're here, right? This isn't quite right because of the parity thing. I expected a lot of like, how many wrong answers did people get on this one? On the top people? Okay, good amount. Some people with a lot actually, but because in theory it should be just 5 plus 6 and not 6 plus 6 here. But I don't have. Oh, because it is on the odd. So you can't really do it the way that I'm doing it. Can ya? Because if it's 0006, then actually you can, because technically you start 1, 2, 3, 2, 3, 4. No, I think that's right. I think this. Okay, I see. Maybe. Okay, so if need minus 1 is greater than 0, then we add it. But if last extra is none, then need something like that, maybe. We have 40. I don't know if this is right still, but in a random 69. But like I said, I'm gonna keep YOLOing because I don't know. I feel like the idea, like the general framework, I think is right, or the idea is in the right direction, but clearly it's not right enough. And I don't know how to, and maybe it's not, honestly, but I think it's something similar. I think there is something about parity that I'm not handling. I'm just kind of trying to see if this hack fixes, but I'm not super confident about it, clearly. Yeah, okay. We have 4, 2, and 9. So I'm giving too good of an answer. Okay, so 2, 2, 2, 2, we have 2. Okay, so if the score is 8, then you have 2, 4, right? Take 7, so this is pretty good. 10, it thinks it's 9. Why? Because it does 3, 5, which is same as 2, 4, but the parity is why. And now you have there's some like one funky thing here. Because we haven't used this yet. Okay, so this is where this thing broke down, actually. So this logic is not good enough for this one. It matters what the parity is. It matters what the parity is for this last extra thing. Because it all... Maybe there's a more direct framework that I'm not understanding. How do you check if you can sneak back and forth? In the minimum number of moves. So okay, so let's say these are the requirements. Maybe I can do a DP instead. There is this odd even parity that I'm not handling right. Because, okay, so let's say we have 3, 5, and that's wrong. Okay, fine. But then what if we have 3, 5, 3? We do 3, 2, 3, but then you're here. So you go here, that's 2, 1, 2, 1, 1, 0, 0. So 3, 5, 3, or 2, 3, but with a parity offset of 1. Is there a better way to think about this? Whoops. Notebook on the keyboard. I feel like I got 2 wrong answers, that's fine, but People got getting it though, really quickly actually. How else do I think about it? Everything else, the framework is fine, maybe. But so how many moves is 3-5? Oops, 3-5. It's gonna be just 10, right? Which does not take advantage of the last extra which I put in here, which doesn't really make sense, honestly. But well, it makes sense if it is odd or something. But I don't want to try that again. But like, so I could write something like that, but that would fix that. But I don't think that's right, because then now you just, you know, this doesn't do anything. No, I want to add. There's something weird like this. I have to handle the. I don't know how a consistent way of handling parity. Okay, so let's just say we look at the pairs, right? Okay, fine. So we can, for every pair we can subtract it by the min. Then now we have these islands or whatever of leftovers. I think the last extra stuff is just weird. Everything else is kind of roughly right, but the last extra stuff is a little bit awkward. But this is going to give me not enough of an answer, because it thinks that I'm making too many moves. For 4 we have 2-1. We think it needs 4 moves, 2-1. Is there a DP? Minimum number of moves that fits these things? Carry one over, maybe? I don't know. I don't even have an idea, honestly. Well, I mean, I was hacking some things together, and I think that it's generally right, but I'm missing one thing. I mean, it may not be greedy, but I'm missing one way of solving it. Can I do DP? Okay, so how do I do like one, two, 1? So I do 1, 1, 0. So I don't know. Solve this or this thing. Minimum number of moves. Okay, so let's say we start one, right? Actually, 0, 1, 2, 1. Okay, so let's say the first number is 1. Okay. That's just 6, 6, 3, right? So 6, 3. Wait, after 3, this is actually on the previous one. So this is, so you want, because if this is 163, then actually no, you do not have to go back to. What is the reduction? Reason is because that's 69. We have 3, 7, 10. So after 3 is 4. But it's 4 with the starting point at the previous one, or maybe the next one. So what is the difference? The parity. The parity is different, but how does it differ? Okay, so 3, yeah. But here, it's 3, 3. Starting from here, but not here. Okay. So it's this thing. Would that be great? This becomes a 4, 10 becomes I think it's more like if I think the other way around, but something like this, something weird like this. Maybe the other way around. Okay, fine. But okay, maybe not. Parity is so weird. Well, it's this part. I think this is maybe right, but then this also needs the parity. Something like this, but awkward. I mean, this fits. I don't know. I don't think this is right still. But I have 20 minutes left and I've done nothing for 20 minutes, so let's get another wrong answer so I can gauge of it. If it times out, that will also be funny. Okay, there we go. I mean, that's not close, but maybe it is. I mean, maybe that's not as not close as it looks. Just because you're just off by 1. Once it's 15, so we start at 311. We think it takes only 6 moves, which is probably not right. 311. 3, 4, 1 is probably the answer, which is 8 moves. Why does it think that then? Oh yeah, because probably just thinks that 3, 2, 1 is good enough, but it's not, because it has to come back. That's where the last extra would have been helpful, but I don't know how to do it. I'm missing something. I feel like there's something dumber for Q4 that I'm missing. Like, we have the requirement away, but I just don't know how to solve for this. Without maybe doing some stupid simulation, which is... Honestly, that's maybe what I needed to do. That's what this is, right? I'm just like off by 1 and all these things. I don't know how to do it. That's kind of silly, but okay. I know I'm having an off by 1, but I don't know how to resolve it. There is something about odd even that I'm not handling right. I'm not thinking about it right. Okay, so 3, 1, 1, right? That's the one that I'm having issues with. How many moves is that? Well, 3. Okay, you have 2 extra, so you have to at least come back. So that's 3, 3. And then 4, and then 1. Okay, well. It's not even like a decreasing thing, because three, 4, 1 is the answer, not 3 for 3, 1, 1. Right? No, maybe 3, 3, 1 actually. Actually, maybe I'm wrong. That I am wrong. It's 3, 3, 1. Well, but still it's 2, it's 1 more. How do I fix it? I don't know how to fix it. I don't know. Then now this doesn't. This works for the other stuff, but not here, because I don't handle the. Oh well, this is just awkward, honestly, and hacky. I mean, even more hacky. But I'm missing some core principle. I mean, this is, I'm putting if statements because I can't figure it out, but I'm missing a core principle. Is the sum of No, but you still have to count the number of moves. You can't just guess them. I don't know. Let's see. So it starts at 1. And every even number something nutty like this, but I don't know. Maybe it's just, I don't know, I wonder if it's a knowledge thing, but 11 minutes left. I've been wasting my entire time in this thing, right? So is there a dumber DP? Do I need to reset? I feel like this is roughly right. The idea. I'm just not entering it, apparently. That's the thing, like 3, 1, 1. So 1, 1, 1, 2, 2, 3, 3. I don't think. I don't even have an idea. I don't know how to, like I don't feel like I'm working towards something. That's the annoying thing. I feel like the framework is right, but I'm not getting it right, clearly. Just one of those days. Huh. And a lot of people are getting it. Having a rough patch. Is there another way of thinking about it with binary search? Maybe looking at the next number. Let's try again. Why not? Maybe I did it the wrong way. I have 8 minutes. What else I have to lose? Okay, so then now times need sub I, and then I want to say need sub I plus 1. So delta is equal to need of I plus 1, or need of I minus 1 minus need sub I plus 1. If delta is greater than 0, then we add it by delta. Yeah. Is that it? Am I just being dumb? No, this is very well. Okay, I mean, at least I almost don't know what I want. So, okay. So then now, oh, and but then now, need of I plus 1 minus need of I minus 1. Maybe. Still wrong. Why? Four, 9, 12. So 4 moves. We go 3. Okay, 6 moves left. So then now it goes 6, 5. Oh, turns. But this is actually plus times 2 minus 1 to come back. Okay, that didn't work. Is that it? I don't know. Maybe, okay. Well, at least it's slightly closer, maybe. 5 minutes left. Not so bueno. Okay, so you have 2, 1, 16 when it should be 12. That means that my answer is too good. Right? So you have 2, 1, 1, 2. So okay, it goes to So it does 3 moves and go to the next one. No requirements. This should be at least 1, right? This is very wrong. At least 0, maybe. Maybe this is also wrong, but that's actually bad though. I don't think, maybe that was that wrong? No, this is right for everything else up to here. But that means that it relies on this being negative somehow, which is actually not great. If need sub I is zero, then we just do, okay, right. Then turns continue. Maybe it was doing some other crazy things. Still wrong, but I don't know. I mean, I feel like it's something roughly like this, but I think this is too much of a hack. Oh, actually, time limited. That's actually not great. I mean, it still might not work, but I want to at least see how Java handles it. I mean, I'm honestly still not that confident about this in general, but what a weird problem. I think I was thinking about it backwards too complicated. With a minute left, so I'm happy. But I mean, the idea I had for an hour, so it wasn't like I got too lucky, but I yeah, 5 wrong answers. But so I did a while, but I think that is the thing about I don't even know if this is quite right, honestly. Like, I wouldn't be surprised if there was a wrong answer that submits this, but oh, because this assumes that in the future you always have numbers left because there's no zero, there's no suffix 0. So I think maybe is that responsive that's right, but it's, I don't know, and time just ran out, so I don't know. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, this contest, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.